Imagine a predator swimming through the ocean right now that was already alive when William Shakespeare sat down to write his very first play. While Isaac Newton was working out the mathematics of gravity, this specific animal was quietly hunting in the dark. When the United States was founded in 1776, an average Greenland shark had already crossed its second century, placing it squarely in middle age. We are talking about the Greenland shark. With an expected lifespan of roughly 400 years, it holds the title of Earth's oldest living vertebrate. Its entire existence plays out in constant slow motion, locked away in the freezing, pitch-black depths of the ocean, where the water temperature sits right at the freezing point. Extreme freezing environments are often associated with short, difficult lives, but the Greenland shark's survival over 4 centuries suggests the Arctic cold might actually be a requirement for its longevity. Their territory covers the extreme Arctic waters surrounding Greenland, Iceland, Norway, and Canada. The cold here is severe enough to freeze the blood of almost any other animal. Yet in this hostile environment, they grow into absolute giants. A mature Greenland shark can stretch 7 meters long, about 23 feet, and weigh up to 1.5 tons. They don't stick to the surface either. They routinely dive to crushing depths of over 2,000 meters, operating like massive, living submarines in total darkness. Out here in the abyss, this massive creature has somehow conquered the one environmental variable that breaks down every other vertebrate on the planet, the relentless passage of deep time. Proving a 400-year lifespan is incredibly difficult. Normally, marine biologists calculate a fish's age by counting the solid growth rings in its bones, much like counting the rings of a tree. But the Greenland shark skeleton is made entirely of soft cartilage, which leaves no solid rings to measure. Because bones were off-limits, scientists analyzed the shark's eyes. The core of a Greenland shark's eyelids forms before birth and remains biologically static for life, preserving a chemical record of the environment from the year the shark was born. By isolating the static core, scientists use radiocarbon dating to measure isotopes and establish a precise birth date. The results shifted our understanding. One female tested at 352 years old. Factoring in the margin of error, she could be over 5 centuries old. This data established a new maximum for vertebrate life, effectively doubling the previous record for longevity. The first pillar of this longevity is the extreme cold. Freezing water temperatures drastically downregulate the shark's metabolism, creating an ultra-low energy lifestyle where cellular wear and tear is kept to an absolute minimum. Their physical growth rate is equally sluggish. A Greenland shark grows exactly 1 centimeter per year, meaning a 4-meter shark has been swimming for centuries just to reach its current size. At the microscopic level, they possess highly advanced DNA maintenance. Their cells have an unusual capacity to repair their own genetic damage, preventing the rapid cellular decay seen in other species. Their physical movement is just as restrained. On average, a Greenland shark cruises at a pace of only 0.3 meters per second. Every aspect of the shark's biology, from its heart rate to its movement, functions as a mechanism to delay cellular decay and extend its lifespan. But this creates a paradox. The Greenland shark is the ocean's slowest shark, and it is often blinded by specialized parasites that attach to its eyes. Yet researchers find the remains of fast, agile prey like seals and squids inside their stomachs. The shark relies on an acute sense of smell to track prey in the dark, using the silent, freezing water to drift within striking distance of seals as they sleep. Evolution has traded speed and sight for sensory perfection and stealth, ensuring the shark can feed without ever having to exert the energy required for a chase. This timeline compares a typical human life to the life cycle of the Greenland shark. A female shark does not even reach reproductive maturity until she is approximately 150 years old. This means a shark must survive for a century and a half before it can contribute to the next generation, a biological investment that is unique in the animal kingdom. For millions of years, this extreme patience was a successful strategy. In a static, unchanging Arctic Ocean, there was no evolutionary pressure to grow or reproduce quickly. The biological traits that allowed them to endure for centuries, late maturity, and slow growth are now liabilities in an environment changing faster than they can reproduce. They are now facing modern threats that their slow-motion biology cannot outpace. Rapid climate change is disrupting Arctic ecosystems, while modern industrial fishing is pushing further into the deep sea. Commercial fishing nets pose the most immediate danger. These ancient sharks are frequently caught as bycatch, tangled in heavy industrial gear that they lack the speed to avoid. The ecological cost is enormous. Because of their 150-year maturation period, if a single breeding female is killed today, it will take the ecosystem over a century to replace her. The Greenland shark is a living time capsule. It proves that nature's ultimate mechanism for survival isn't aggression or speed, but an extreme form of biological patience. However, a species evolved for a world that moves in centuries is now finding itself at the mercy of a world that changes in decades.